All right, so this is going to be the test review worked out. We're going to start with number 1. I forgot my little writing thing at school, so this may be a little bit ugly. So to find your absolute maximum, we need to start by finding the critical numbers, which we do by taking the first derivative. So the first derivative of x would be negative 2x plus 4. And then our critical numbers are wherever the first derivative equals 0 or it does not exist. My dog. Just looking at this, though, you can see that it exists everywhere, so we don't need to worry about that. And we can just set it equal to 0. So 0 equals negative 2x plus 4, which means 2x equals 4. So x equals 2. So that's going to be our only critical number here. But when we make the chart, we're going to also have to include the endpoints. So I have f and f of x. My two endpoints are 0 and 4. And then I have my critical number, which is 2. So I'm going to plug in each of these to the original, not the derivative. So it'd be negative 0 squared plus 4 times 0 plus 1, which means our y value here is a 1. When I plug in 2 squared, so plus 4 times 2 plus 1. So 2 squared is going to equal 4. So we'd have negative 4 plus 8 would be positive 4 plus 1 would be 5. The last one, I'm going to plug in a 4. So I have negative 4 squared plus 4 times 4 plus 1. Negative 4 squared would be negative 16. Plus 16 is 0. Plus 1 would be 1. So from this, we can see that our absolute maximum value is going to be right here at the point 25. So the absolute max at the point 25. And then that's all the work that supports it. Okay, number 2. It's going to be the same thing, except we're looking for an absolute minimum. And this time we have, this should be f of x. It just looks like an x. So f of x equals sine of 2x. Still going to take the derivative to start. And this one will be using chain rule. So the derivative of sine is going to be cosine, but the inside will stay the same, times derivative of the inside. Derivative of 2x would be times 2. Now to find our critical numbers, again, it's either going to be where it does not exist or where it's equal to 0. It exists everywhere, so we're just going to set it equal to 0. My dog is making some noises. All right, so 2 cosine of 2x is going to equal 0. And if we divided by a 2, we'd still get 0 equals cosine of 2x. So we just need to figure out where cosine of 2x equals 0. So if you think about your unit circle, we know that cosine of x equals 0 when x equals pi over 2 and when x equals 3 pi over 2. But since we have this 2 on the inside of our parentheses, we need to figure out what can we multiply by 2 to get these two options, which would be x equals pi over 4 and x equals 3 pi over 4. And just to test that out over here, so if we had pi over 4 times 2, this would become, the 2's would cancel out, so it'd become pi over 2, which is what we want for it to be equal to 0. Same thing with 3 pi over 4. When you multiply that by 2, it becomes 3 pi over 2. So these are not our critical numbers. It's actually x equals 4 and x equals 3 pi over 4 because there's a 2 on the inside of our parentheses. So let me erase these real quick. Okay, we're still going to make that same chart though with these two critical numbers in our endpoints. However, if you look, it's from the interval of pi over 2 to pi. So really, pi over 4 is not in that interval. We don't need to worry about it. So here's our chart. We have x and f of x. And we have pi over 2, 3 pi over 4, and pi. Then we're going to substitute each of these into our original equation, which is sine of 2x. So if I have sine of 2 times pi over 2, it's just going to be sine of pi for the first one. And sine of pi is going to be 0. Then sine of 3 pi over 4 times 2 would be sine of 3 pi over 2, which would be -1. And then lastly, we have sine of 2 pi. And sine of 2 pi is also going to be 0. And we're looking for an absolute minimum here. So you can see that our minimum would be right here at the point 3 pi over 4, -1. So my absolute min at the point 3 pi over 4, -1. Okay, then we move on to 3. 3 has 4 different parts, A, B, C, and D. Now for part A, it wants us to identify the values of relative extrema and justify your answer. B also kind of goes along with this one because we're trying to identify the intervals where it's increasing and decreasing. So I'm going to start off. A and B are going to use the first derivative test. So f prime of x is going to be x squared minus 3x minus 10. And this is defined everywhere, so we just need to figure out where it's equal to 0. And I can go ahead and factor this into x minus 5 and x plus 2. Now the cat's making noise. So we can see that our critical numbers are x equals 5 and x equals -2. Now from here, we're going to make our chart. So this is going to be the different kind of chart. It's going to be a horizontal line. We don't have endpoints here, so it's just going to be -2 and 5. On the top, we're going to put the sign of the first derivative. On the bottom, we're going to put if it's increasing or decreasing. So I need to pick a number that's less than -2 and a number less than -2, so let's say -3. And you're going to plug this back into your first derivative, not the original, since we're looking for the sign of our first derivative. So if I plugged in a -3, I'd have -3 minus 5, that would be -8, times -3 plus 2, that's -1. So a negative times a negative would give me a positive number. We don't need the number, we just need to know if it's positive or if it's negative. And I just plugged it into the factored version. That's the same thing as plugging in to the first derivative because those are really the same thing. Okay, now I need a number in between -2 and 5. The easiest choice here would be 0. If you plugged in a 0, you'd have -5 times +2, which would be a negative number. And then a number greater than 5, so I could say 10. I'd have 10 minus 5 is +5. 10 plus 2 is +12. So the first derivative would be positive there. And from what we learned with the first derivative test, when f prime is positive, it's increasing. F prime is negative, it's decreasing. Positive, it's increasing. So for A, we need to identify the x values of the relative extrema and justify your answer. So what we have to do here is look. So you can see there would be a maximum, relative maximum at x equals -2. And our justification there is because f changes from increasing to decreasing. And then if we look here, we have a relative min at x equals 5. Because f changes from decreasing to increasing. And of course, we know this because of the first derivative test. All right, so that's our answers to part A. Okay, so now to just make space, I'm going to erase this really quick. To answer B. So I'm going to identify the intervals in which it's increasing and decreasing. So first off, it's going to be increasing on the intervals from -infinity to -2 and from 5 to infinity. And the way we know this is because f prime is positive. Then it's decreasing from -2 to 5 because f prime, not double prime, f prime is negative. So those are the answers to A and B. Now we're going to need to find the second derivative and use the second derivative test for C and D. So I'm going to erase everything except the first derivative because we're going to need that to find the second derivative. So our second derivative is going to be f double prime of x equals 2x minus 3. And again, this is defined everywhere, so we don't need to worry about that. We just set it equal to 0. Which means 3 equals 2x. So 3 over 2 is going to be our possible inflection point here. I'm going to make another chart. This one I'm going to have f double prime on top and f on bottom. So you have 3 over 2. I still need to pick a number that is less than 3 over 2, and then I'll need to pick a number that's greater than 3 over 2. So a number less than 3 over 2, 0, is the easiest one. And you're going to plug this back into the second derivative because we want the sign of the second derivative in that interval. So if I plug in a 0, I would get -3. So it would be a negative there. If I picked a number bigger than 3 over 2, I could pick 2. 2 times 2 is 4, minus 3 would be +1. And we know if our second derivative is negative, it's going to be concave down. If our second derivative is positive, it's going to be concave up. So now we can answer C and D. So for C, discuss concavity. So we can say concave down. On the interval from negative infinity to 3/2, because f double prime is negative. And it'd be concave up on the interval from 3/2 to infinity, because f double prime is positive. Sorry for my ugly handwriting. And then our last part wants to know where any points of inflection are. So I'm going to erase this real quick. So the point of inflection is if it changes concavity, and we can see that it does here. So the point of inflection so we know that the x value is going to be at 3/2. Because it changes from concave down, f, because f changes. So make sure you specify what you're talking about. F changes from concave down to concave up. So that would be our point of inflection. That's only the x value of it. I'm not sure if I wanted the y value, but I'm out of room. If you needed to find the y value, which I think you may need to here, we know that x equals 3/2. You can just plug that back into our original to find the y value at that point. I trust you can all do algebra. All right, and that's the review.